नहीं, लाइव स्ट्रीमिंग चेक, लाइव स्ट्रीमिंग की आउटपुट का लिंक आउटपुट नहीं पता।
The person you have called is speaking to someone else.
हेलो, हाँ जी विभू, आपको लाइव स्ट्रीम में आ रहा है?
हाँ, वो आपका वेबएक्स दिख रहा है।
सिर्फ वेबएक्स दिख रहा है? लोग, मैं भी पीपीटी उसमें ऐड कर रहा हूँ, मुझे बताना वो दिख रही है। ये लाइव स्ट्रीम का हमें लिंक शेयर कर दोगे जहाँ पे मतलब वी कैन सी।
मैं आपको शेयर करता हूँ, मैं जस्ट।
हाँ ठीक है, ठीक है। Rahul, can you hear me? आपका लाइव स्ट्रीम में you are able to see this whole presentation? ठीक। ठीक है जी, ग्रेट है। इसमें राहुल एक ये, अच्छा मुझे ऊपर वाले जो आए थे आपको, ये नहीं आने चाहिए थे, इसके लिए मैं कुछ क्या करना है देखना, एक मिनट देखना। हाँ जी, नहीं 34 तो आएगा, बट जो, नहीं 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 नहीं, जो ऊपर दो आइकन्स आ रहे हैं ना, अच्छा ये फुल स्क्रीन में नहीं होगा तब की है, ठीक है ठीक है, ऊपर आपका और मेरा होस्ट जो, हाँ नहीं वो जब फुल स्क्रीन मोड पे नहीं होगा तो हट जाएगा ना। Got it. तो इनोगल में तो बस यही लोग हैं ना, अप टू आर के, अच्छा सरस्वती की एक स्लाइड और ऐड करनी पड़ेगी। अभी मेरी स्क्रीन नहीं दिख रही है ना आपको? ठीक ठीक। राहुल ये लेफ्ट वाला आपको रीसाइज करना है। राहुल, ये आप व्हाट्सएप ग्रुप में देखेंगे मैसेज जो आ रहे हैं। हम्म। ये एक्चुअली मेरे पास तो लाइव वो नहीं है। आप अच्छा एक ही लैपटॉप से हो क्या? बैकअप लैपटॉप है आपके पास? अच्छा, ये मुझे नहीं, मैं क्वेश्चंस में गया था। विजिटर्स, फॉर्म्स एंड सर्वेज, मार्केटिंग सर्वेज। चलो मैं वीडियो प्ले कर देता हूँ। कीनोट, हाँ जी। वेबएक्स शेयर मोशन वीडियो।
Good morning, good afternoon, good evening, depending on wherever in the world you're participating in this conference from. I've been associated with the VLSI conferences right since its inception, but this year it is different. It is the first virtual VLSI Design and Embedded Systems Conference, and Cadence is delighted to be a Silicon sponsor for this year's conference. For this specific keynote, we're going to do it a little bit differently. I'm going to start off by sharing some high-level industry trends, and then I'm going to hand it over to Paul Cunningham, who is the general manager of our systems and verification group, who's going to talk to trends in the cyber physical systems domain and talk about how Cadence is addressing those challenges. So let's get started. Once in every generation, there is a disruptive technology that redefines the industry landscape. In the last decade, that was mobile computing. It is absolutely unprecedented that today we are seeing 5 such disruptive generational trends. These are 5G, hyperscale computing, artificial intelligence and machine learning, autonomous vehicles, and industrial IoT. And they're all anchored around generating and processing large quantities of data. And they're all enabled by computational software. So in reality, it's computational software that's driving the future of the technology landscape. If you look at the data, the very large quantities of data that's being generated, that needs to be transmitted, it needs to be stored, it needs to be processed, and it needs to be analyzed. And this indeed is driving the tremendous silicon renaissance. If you look at some of the specifics here, 90% of the data that exists today was generated just in the last unstructured, which means the conventional ways of analyzing the data break down. And that's the reason why only 2% of this data is being analyzed today, which means only.
Anji, yes. ये तो कॉन्टिन्यूस मेरे यहाँ पे तो कॉन्टिन्यूस चल रही है ये क्या करें मीटिंग में दोबारा प्ले करूं वीडियो
2% of the data is being meaningfully used. If you project this into the future, industry sources say that over the next 5
Alexa is basically the parent in our house.
ऑडियो मोशन वो मैंने सिलेक्ट किया है
Ask it for our future is absolutely one of intelligent
ऑडियो आ रही है
devices. See, hear, touch, cars that drive themselves, homes and offices that intelligently control. And of course, with this scientific revolution, an explosion of new semiconductor design.
कर दिया फुल स्क्रीन मैंने
From the data center to the edge, to a smart grid in our offices and factories, to medical devices, cars, industrial equipment, process control systems and robotics. Everything that happens in this cyber-physical revolution relies on semiconductors. Analog, digital, mixed signal, chip to package to board. A continuous blurring of the lines between hardware and software. So how does this cyber-physical revolution relate to the EDA industry? The key thing we're seeing at Cadence when we talk to our customers is a shift in mindset. Our customers are no longer just looking for a partner to automate their design. They're looking for a partner to help differentiate their products. It's not just about automation, it's about automation with the best performance. And their challenges are not only at the chip level. It's performance of the overall system that the chip goes in, and performance of the end applications built on these systems. And these systems are no longer static systems. They're intelligent learning systems that are continuously evolving and customizing their user experiences. At Cadence, we feel perfectly positioned to respond to our evolving customer needs. If you step back from our products themselves and ask the question, what makes the people at Cadence so special, so unique?
The order in which you see on the
You come
website
to the
photograph,
conclusion
this is the same order.
that what Cadence has built over the last 30 years
Okay.
is one of the world's best computational software teams. We have more than $2.5 billion in revenue and spend 40% of this on R&D engineers who know how to write very complex computational software. We have many of the world's experts in numerical solvers, SAT solvers, SMT solvers, graph algorithms, computational geometry, and so on. At Cadence, we are taking our core competency in computational software and using it to create new products and new value at the system level. We're also taking this same expertise and using it to make our own solutions intelligent and intuitive. We call this our intelligent system design strategy. And I feel it's a perfect strategy to help fuel and enable the cyber-physical transformation that is going on around us. A perfect example of us leveraging our strength in computational software to grow from design performance to system performance are our Celsius and Clarity system analysis tools, which we launched last year. These tools are entirely homegrown at Cadence and build on our deep computational software expertise in advanced, massively parallelized matrix solvers in the SPICE and power sign-off markets. With Celsius and Clarity, we leverage this expertise to enter the system analysis market of finite element solvers and fluid dynamics. Celsius and Clarity are disrupting this market with solutions that are just 10x faster and much more scalable than existing products. And our journey here is still just beginning. Our original Clarity launch last year was with a frequency domain-based solver. This solver has the best accuracy, and we can scale it way beyond any other tools in the market. For example, we can run an electromagnetic simulation of an entire DDR DIMM. Now, more recently, just last quarter, we extended Clarity to include a time domain-based solver. While not as accurate, this solver has almost unlimited scalability with a distributed architecture that is cloud-enabled. It can be used to simulate a whole car or airplane. Putting these two solvers together in one unified solution is a truly amazing technical algorithmic achievement. And most recently, just last month, we announced an agreement to acquire NUMECA, accelerating our ramp into computational fluid dynamics. Another key thing we've been able to do by building Celsius and Clarity from the ground up at Cadence is to integrate them tightly with our design tools to offer a truly unified solution for both design and system 3D IC performance. Here we've connected together tools across all of Cadence, from PCB to IC to interposer to interconnect, to allow concurrent implementation of a 3D IC across multiple teams, but while also enabling continuous system-level analysis of either individual dies or the whole 3D IC package for power integrity, electromagnetic, or thermal. It's a beautiful solution and something Cadence is uniquely privileged to offer as part of our intelligent system design strategy. Another great example of our intelligent system design strategy at work is our Palladium and Proteum dynamic duo. Cadence has been a market leader in emulation for more than a decade with our flagship Palladium emulation system. Palladium uses a custom proprietary processor we design and tape out here at Cadence. It's the ultimate chip debug accelerator, offering lightning-fast, predictable compiles and the ability to stop, start, and probe any signal at any time. But now, Palladium has a system-level partner, Proteum. Proteum is targeted at accelerating pre-silicon embedded software debug. Proteum runs 3 to 5 times faster than Palladium, but like Palladium, it also comes in a standard data center rack scalable to multi-billion gate designs. We've also designed Proteum from the ground up with a unified compile flow and unified transactors and hardware connectors to make it very, very easy to move a design from Palladium to Proteum as your chip stabilizes and the focus moves from chip debug towards software debug. Where Palladium is our customer's ultimate debug machine, Proteum is their ultimate performance machine. And they can buy whatever mix of each achieves the highest verification throughput for their specific product and end market needs. A final example of Cadence's move from design excellence to system-level innovation is our Tensilica configurable processor and DSP design IP. Here we're fusing our deep expertise in computational algorithms with a world-class configurable extensor processor architecture to offer a comprehensive family of system-level compute solutions. If there is one element of our Cadence solution today that is most spearheading our commitment to a cyber-physical future, then it is Tensilica. This unique technology can enable audio, radar, LiDAR, vision, all with a common configurable architecture and all with industry-leading performance per watt. Okay, now let's move from system innovation to pervasive intelligence. Just like machine learning is central to the cyber-physical revolution, machine learning also absolutely has the potential to transform almost all our products at Cadence. We're now able to take designer intuition and encapsulate it in an algorithm. A first great example of this is in our Innovus place and route system. Here, despite decades of investment in deductive algorithms to pick the best logic placement, best signal routing, best clock tree topologies, and so on, the harsh reality is that our customers still perform many, many trials of place and route with different settings, scripts, knobs, and so on to achieve the best overall power, performance, and area, or PPA, as we call it. By putting machine learning into Innovus, we're able to begin to automate this iterative manual process and drive significant improvements in PPA without any human needing to be in the loop. And honestly, without any direct deductive understanding of place and route in and of itself. It's a abstracted black box optimization through intuitive machine learning and neural network training. It's amazing, really. And our journey here is just beginning, but the early results, as you can see, are already very impressive. Another example of machine learning at Cadence is our new Excellium ML solution. Now, a significant fraction of our customers' digital logic simulation workloads are with pseudo-randomized test benches, for example, with a UVM environment. These tests are typically grouped into banks of thousands or even tens of thousands of tests, all of them firing pseudo-random stimulus to try to catch corner case bugs. It's an extremely compute-hungry task, but also not a very efficient one. Much of the compute resource is consumed by this randomized stimulus, injecting values into the design that cover points already covered by previous randomized stimulus. Essentially, it's just covering what has already been covered before, time after time after time, with only a very infrequent increase in the actual coverage to find new parts of the design or functional specification. What we've done with Excellium ML is to build an AI system that can learn from the last time the tests were run and guide the randomization kernel inside our logic simulator, Excellium, to be smarter. I say to load the dice, as it were, to roll a 6 more often and hit the required coverage points with dramatically less compute resource. Again, as you can see, it's early days for us, but this technology is showing very compelling results and has very, very strong traction amongst our customer base. So, before I wrap up, I really wanted to acknowledge that intelligent system design, and indeed a cyber-physical future for all of us, cannot be realized by Cadence or any one academia, hardware and software challenges, system versus chip versus fab, packaging, design automation. Only together can we do great things and shape the future. So, thank you all for your time today. It has been a privilege to have the chance to talk with you about Cadence and our intelligent system design vision, and how this vision is, in our view, a key enabler and a key contributor to the ecosystem to deliver a cyber-physical future for us all with real societal changes for the better and for the greater good of the world. Please take care, stay safe, and stay healthy.
So now I would like to thank Paul for his insightful talk on cyber physical systems. systems. So how this whole is changing the world in the times to come. So with that, we'll now move to the next talk. Next talk is by ST. I would like to thank Paul for his insightful talk here. Now it's time to move to the next talk, which is by ST Microelectronics. So I'd like to welcome the speaker for the talk, and here he goes.
Good afternoon. It's a pleasure. Many great teams in ST Greater Noida, which is one of the highlights of my career. So I'm glad to be here with you today virtually in Bangalore. I'll share a view on Industry 4.0 as an industrial player ourselves and the key role of cyber physical systems with some concrete insights based on our wafer fab experience and on our SoC product development. Let me start with a short introduction to ST for those of you who may not know us. ST is a technology company. We are an independent semiconductor manufacturer among the largest chip-making companies in the world. Our 46,000 employees, of whom nearly 8,000 work in R&D, create and make technologies and products to serve the needs of our broad customer base. We work with our 100,000 plus customers and thousands of partners to design and build products, solutions, and ecosystems that address their challenges and opportunities. We master the complete semiconductor supply chain with state-of-the-art manufacturing facilities around the globe for front-end and back-end production. You find ST products in many automotive applications, making them safer and greener. In smart homes and smart cities for better living, more security and energy efficiency, and many everyday things, making them smarter and more connected. We also participate in making industry smarter and safer, and this will be the focus of my presentation today. Cyber physical systems are enabling the Industry 4.0 transformation. For smart industry itself, by making possible more agile, safer, and autonomous industrial systems, while saving energy and improving manufacturing productivity. In industrial, Internet of Things, and 5G, first, 5G facilitates connectivity to the cloud. Therefore, this fosters the many different connectivity standards for IoT, which I will describe later. Second, end-to-end security is extremely important, especially with devices that are accessible remotely. Thus, security is a critical part of cyber physical systems. Third, the processing power of today's MCUs, including the STM32, is growing, enabling AI-based decisions at the very edge, where the data is generated, ensuring low latency, privacy, and energy efficiency. Finally, smart cities are about building a more efficient city infrastructure, enhanced mobility services such as e-bike rentals and smart parkings, and more energy efficiency. Key applications include smart LED street lighting, which can save up to 50% on the lighting electricity bill, which is significant for a large city. Our vision of Industry 4.0 is the following. In smart factories, all production steps are digitally mapped in the form of a digital twin and linked to one another to facilitate data exchange. Cyber physical systems, or CPS, are at the core of Industry 4.0 by capturing and processing the data feeding digital twins. Here are the technology blocks composing CPS. First, the embedded processor is transforming data into information that is sent to the cloud or possibly used locally for autonomous decisions. The processor will also drive the actuators. Motion sensors that are more accurate, efficient, and faster are enabling the sensorization of the factory. Actuating is more energy efficient thanks to new compound semiconductors like silicon carbide or gallium nitride. Autonomous decisions are now possible with AI and machine learning at the edge. Many connectivity technologies are necessary for Industry 4.0, Wi-Fi, Bluetooth, LoRa, narrowband IoT, LTE Cat-M, depending on data throughput and data range. Ultra-wideband is used for centimeter accuracy localization, as I will explain later. NFC allows communication with smart RFID tags for the warehouse or the factory floor. Security is a must for CPS. The system must be secured to ensure device integrity, safe and trusted software upgrades, and data transmission protected against eavesdropping, corruption, and malicious modification. Let me now focus on the 4 blocks on the right of this picture. Starting with embedded processing. Industry 4.0 fosters thousands of applications and is requiring relentless product innovation. Let me illustrate this fragmentation with the STM32 portfolio, which is representative of this trend. While this portfolio contains more than 1,000 part numbers, we still invest significantly in mainstream MCUs, such as the G4 series, tailored for high-performance motor control and other industrial applications. In ultra-low power and security, we introduced in 2020 our fully certified L5 series based on the ARM Trust Zone and the latest Cortex-M33. In wireless, the STM32WB and WL series are covering Bluetooth Low Energy and LoRa Sigfox low power wide area networks. They are both in volume production. In high performance, we have introduced dual core architectures with the STM32H7 series, among the fastest MCUs on the market. Finally, we keep extending our STM32MP microprocessor family, offering now an 800 MHz product and a dedicated ST Linux distribution. All the above products are supported with our advanced ecosystem, the STM32Cube. Next, the number of connectivity standards is growing. Each standard is developed to better serve specific use cases of Industry 4.0. Low power, short, medium range technologies like Bluetooth Low Energy and Zigbee are geared towards smart things in smart buildings. The long range, low power communication technologies like LoRa and Sigfox or cellular narrowband IoT with LTE Cat-M are focusing on the smart factory and the smart city. We are seeing growth in NFC and soon ultra-wideband for asset tracking applications. To overcome the challenges of RF design and certification, we offer a range of certified modules with Bluetooth, cellular or LoRa, and integrated system on chips for Bluetooth Low Energy and LoRa in order to accelerate CPS product development. To develop connectivity-based CPS, it is mandatory to start from boards that are already RF ready with CEC, FCC or equivalent certifications already in place, as is shown here. In the same domain of connectivity, NFC tags and readers are providing a vast array of applications pertinent for Industry 4.0. The pervasion of NFC contactless application is illustrated here on the left. First, lighting, for which each LED driver settings is being factory programmed. Metering for installation setup, for meters for water, electricity, and gas. Factory automation with product personalization during production, even when the device is powered off and already packaged in its cardboard box. Smart logistics for asset tracking, in particular cold chain monitoring, which is very pertinent right now. Power tools for accessories, identification, and automatic tools parameter settings. Several standards organizations are ensuring that all suppliers are interoperable and are shown at the bottom right of this slide. First, the industry technical standard for NFC is managed by ISO with the standards 14443 and 15693. Second, the NFC Forum is encouraging and making visible the complete industry ecosystem for NFC. Finally, the Zaga Consortium, created recently, is a global lighting industry organization that aims to standardize the interfaces of components of LED luminaries. These standards enable companies such as ST to provide a set of optimized hardware products, including readers, tags, and dynamic tags, as you can see in the center. Tags are batteryless and powered by the reader wirelessly for read and write operation. Dynamic tags can be read or written either by an RF reader or alternatively by an MCU through an A2C wired connection. NFC products, as you can see, are made easy to use for CPS developers thanks to a complete ecosystem, including hardware boards, software libraries, mobile applications, and smart antenna design tools, because indeed the antenna is a key component of the success of the whole system. Let me now focus on ultra-wideband technology. In IoT, ultra-wideband is enabling asset tracking with centimeter accuracy for warehouses and factories. This is used today in production by our partner Trumpf in Germany in their sheet metal factories.
So team, with this, we'll now close this session 0. We'll see you after lunch for the second run. Thank you. Bye-bye. Rahul? Hello? Rahul, can you hear me? Rahul, we'll close the session 0 now.